Hey guys, welcome back for lesson 3-2, where we're going to be talking about conditional statements. Make sure you have your springboard ready to go, a pen or a pencil, and a highlighter, because of course we're going to be getting some more vocab words today. So going over our targets really quick, we're going to be identifying the hypothesis and conclusion for a conditional statement. And then we're going to be able to give counter examples for false conditional statements. Okay, so we're on page 29 here. So let's talk about actually what a conditional statement is then. Okay. So a conditional statement is an if-then statement. Okay. So rules of logical reasoning involve using a set of given statements along with a valid argument to reach a conclusion. So we're going to be given statements here or conjectures that are in the form of if-then. Okay. The if clause we call the hypothesis. Okay, kind of like in science class, you make a hypothesis, you predict what's going to happen. So that's our if clause. Our then clause is what we call the conclusion. Okay. We have an if-then statement, which we call a conditional statement. The if is the hypothesis, the then is the conclusion. Okay, and a lot of times they're going to refer to these as, sometimes they, for just general forms, they say something like if P, then Q. So again, in our situation here, P would be our hypothesis. Q is our conclusion. Okay, and this kind of comes from this little writing math term over here too. Okay, so let's look at an example. Example A here, where they have this conditional statement. If x plus 7 equals 10, then x equals 3. So they're going to ask us here, what's the hypothesis and what's the conclusion? So something important to note that I made a little side note over here on the right is the hypothesis does not include the word if. It's just the phrase that comes after it. So in this case, if we have if x plus 7 equals 10, the hypothesis is just the phrase or the clause that comes after the if word. So our hypothesis is x plus 7 equals 10. Okay. Similarly with the conclusion, you don't include the word then, it's just the phrase after that. So in this case, our conclusion would just be x equals 3. Okay. The if and the then, we would just consider those as like the trigger words to tell you, okay, this is the hypothesis part, and then this is the conclusion part. Okay. All right, question C, state the property of equality that justifies this conclusion. Now, if you remember from our previous lesson when we were solving equations and writing proofs, if I have x plus 7 equals 10, what property did they use to get to this conclusion where that x equals 3? Hopefully you remember that we call that the subtraction property of equality. Right? Okay. So it's not any harder or easier than that. It's just looking for those if-then clauses. Okay, so let's move on here. So conditional statements may not always be written in the if-then form. Okay, sometimes they're a little out of order. So we have on the side here a couple of different options that these conditional statements can be written as. Okay, so if P then Q, that's the normal statement. That's how we like to see it. But it also could be written as P only if Q, P implies Q, and Q if P. So remember, P standing for your hypothesis, Q is always the conclusion. So let's look at an example from your book where it says, I'll go if you go. So we don't have the if-then statement that we're used to seeing. It's kind of using this bottom kind of form right here, where it's giving the conclusion first and then the hypothesis second. Okay, I'll go if you go. So we have to rewrite this conditional statement in an if-then form. So we want if something happens, comma, then we'll have a conclusion. So what's hypothesis then? What are they saying first? Well, they're saying if you go, The conclusion then is, then I'll go. Okay. Kind of like if you were going to go to a party with your friends, you wouldn't want to go by yourself. So you tell your friends, if you go, then I'm going too. Okay. So let's look at B then, where it says there is smoke only if there is fire. Okay, this is kind of a phrase you might have heard before. So try to rewrite that using an if-then statement. How would you rewrite that as an if-then? There is smoke only if there is fire. Okay. Hopefully you realize that the if statement is there's fire, because that's your hypothesis. The conclusion then is then there is smoke, right? So if there's fire, then there is smoke. All right, C then is using that implies form. Okay, so it's kind of this one here, P implies Q. But they're saying x equals 4 implies that x squared is equal to 16. So go ahead and rewrite that using an if-then statement. Okay, hopefully you rewrote it like this. If x squared is equal to 16, then x is 4. Okay, so really think about if-then statements kind of like cause and effect. Okay, if something happens, then you're going to have a reaction to that. Okay, so think of that when you're trying to think of the order. All right. Lastly, what we're going to talk about is something called a counterexample. Okay, an if-then statement is false as if an example can be found for which the hypothesis is true, but the conclusion is false. So they'll say something like if you're my friend, then your favorite food is hamburgers. Okay, where my hypothesis is true, you're my friend, but the conclusion could be false. Maybe you don't like hamburgers. Maybe your favorite food is pizza, right? So the pizza would be your counterexample, okay? So let's look at this false conditional statement. If two numbers are odd, then their sum is odd. So if you take two odd numbers and add them together, you should get another odd number, is what this statement is telling us. So let's look at this. What is our hypothesis in this sense? So remember, look for that trigger word with the if. The clause that comes after it is your hypothesis. So our hypothesis here is two numbers are odd. What's our conclusion then? Okay, the conclusion is their sum is odd. So remember, you don't include the if and the then when you're talking about hypothesis and conclusions. They're just your trigger words to tell you what's what. So we know that this is probably a false conditional statement. So I want you to think of a counterexample and justify your choice using this example. So what's a counterexample where two numbers are odd, but you add them together and you don't get an odd sum? Okay. The example that comes to my mind is the numbers 1 and 3. They're both odd numbers, but if I add those together, what do I get? I get 4, which we know is an even number, right? Okay. So not all conditional statements have to be true. If you can think of a counterexample, then you can prove it's being false. Okay. All right, so just one more example that you guys are going to try. This is number 6 down here, where it says Caesar conjectures that the quotient of any two even numbers greater than 0 is odd. Okay, so Caesar is saying you divide two numbers, even numbers that are greater than 0, and your answer should be an odd value. So I want you to rewrite his conjecture as an if-then conditional statement. So go ahead and try that right now. Okay, here's what your book has. So they have, if two numbers greater than 0 are even, then their quotient is odd. So that's what Caesar is saying here. Now, do we think Caesar's conjecture is false? Right? So if you think it's false, then give me a counterexample to something that could prove that it's false. Okay, so this is the example that the book gave, not necessarily the example you had to come up with, but they said if I take 8 divided by 2, those are two even numbers greater than 0, But when I divide them, I don't get an odd result. I get 4, which again is an even number. Okay. So that's all for today's lesson, just talking about conditional statements, if then, and knowing that they're not always necessarily true. If you can give a counter example, you can prove that something is false. All right, guys, I'll see you for the next lesson.